See, I'm on the bus. And I'm finna go on YouTube. So I'm the first one on the bus. So I don't want to get copyrighted odds and y'all, so I'm inside. I think I was on the bus. Make science. So this is like the second to almost last.
Over a year ago, September 23, a big drought. Showing a little bit more with all the wildfires. September 15th.
Yeah,
That drought.
yeah.
See all these wildfires in Canada. Do you remember the smoke that kept coming down into Indiana last year? It was so smoky, cloudy looking around here for a while. That was from all of those wildfires. All right, next one, hurricanes powered by warm ocean water. Powered by warm ocean water. Hurricanes are the same as typhoons, which are the same as tropical cyclones. They're just called different things in different parts of the world. So Atlantic and East Pacific, say hurricane, West Pacific, typhoons, Indian Ocean, Australia, cyclones. All of them have this in common. They're the same thing, but they draw heat from warm water. We'll watch this news report from a meteorologist, and then he talks about how this actually happened really fast, but then why this hurricane developed really fast.
So struck in the weather tonight, they gave very few weather models that meteorologists look to actually picked up on the rapid intensification that it actually went through. In a 24-hour period, it was impressive. It took advantage of a very narrow swath of ocean water temperatures at about 88 degrees Fahrenheit. And that's significant because for rapid intensification to carry on, it actually needs to be 80 degrees or higher. And it found just that water and strengthened rapidly, 165 miles per hour. This is the first Category 5 landfall to impact the eastern Pacific, the strongest storm to strike the Pacific coastline of Mexico, and the fastest 12-hour rapid intensification for this area. It is that 12-hour window where it rewrote the history books, rapidly intensifying by 90 miles per hour, but the overall picture in a 24-hour period, 115 miles per hour strengthening. That is incredible, mind-boggling to be quite honest. Acapulco, not only a tourist destination, but it has a residency of about 1 million people. So with a direct hit like this over a major metropolitan area, starting to see the first visuals of the damage that was left behind, not only by the wind, but also the storm surge. It's a Category 2 now. It is weakening rapidly, 110 mile per hour winds. That is starting to interact with the mountainous terrain of the Guerrero State. It will rain itself out.
Thunderstorm. The wet, hot air rises and forms a thundercloud. Wet, hot, and then it says wet. It's really important.
It hurts.
So the big
I got hit my
question
shoulder
is,
multiple
are we
times, so
facing
it
a
made
new
me in
kind
a
of
little bit
living
area.
scenario? Prefer not to think about climate
I
change
feel like a
and global
muscle
warming in
pull or
terms of doom
something.
and gloom scenarios, so much as a change in our planet. Our planet's definitely changing, and we're
Oh my
definitely causing it.
god.
So we're going to have to learn to deal with some of
It
these
hurts like
changes.
this.
In
And right
addition,
here,
we're going
like
to have to
so.
learn how to make
Like it
a
hurts like
slightly
stabbed me.
smaller
My
footprint.
muscle hurt. It feel like somebody punched me 1,000 times. In my arms. It still hurt.
Sea level is rising. The water actually expands and takes up more room. The other thing that happens is that ice that was on land in the form of glaciers and ice sheets begins to melt, and as that runs off into the ocean, it increases the water in the ocean, and it actually raises sea level as well. It's important to understand how the world's ice sheets form, how they change over time, and how fast they are moving. Beaches, as sea level rises, then beaches begin to erode, and we begin to lose wetlands. A lot of different ecologically sensitive regions lie along the coastline, and as sea level rises, these get flooded, ecosystems are forced to change. So all this can have big consequences for people, and especially people who live near the coast. As the great ice sheets in Antarctica and Greenland begin to melt and break up due to global warming, we really might experience very rapid sea level rise, 3 to 4 times as fast as the rate that we see today. So predicting this rate out into the future is very tricky because we really don't know when the ice sheets might break up and how fast they will when they do. So predicting future sea level rise is one of the great scientific problems of just some global headlines. This is also from last year. 10 countries, territories saw severe flooding in just 12 days. Heat wave, flooding disasters. Just some pictures of drought. This is catastrophic flooding here killed at least 3,958. I think this was after the flood. Sorry, not drought. This is after quite devastation. This comes after strong floods around the world. This one from China to Brazil to Greece and everything was all right, so here's all that you saw. What do you see in common with all the causes? Hot air, increased temperature, warm, hot, acid heat. So why did it happen? Increased temperatures from climate change.
Let me see.
Increased temperature from climate change. Now we know climate is over a long period of time. It's not just a hot summer or something that's just a season. It's over a longer period of time. Okay, so increased temperatures from climate change are creating more heat, and then the heat drives these extreme weather events. billion weather and climate disaster. You can see lots of different areas all over the United States where there was a huge amount of money. I need to go through this with you, also pick some along the way. So you have a graph. What I want to do is be able to look at weather conditions over decades and see if we can see some of the patterns. So we've got droughts, severe storms, hurricanes, and wildfires. And we're going to look at them starting in 1980 and going all the way through to 2020. So each of these are a decade, which is 10 years. So we've got 10-year periods, so 1, 2, 3, 4 different decades of data. Okay, so in this case, we're going to start with a drought, and we're just going to go from one decade to the next and plot. So stay with me on drought for now, and we're going to plot it all the way out, and then you can do the rest of them. All of these are going to be in a different color. So let's start with drought. Everybody look up. So in 1980 to 89, that decade, we look at drought. This is events per decade. So there were 5 droughts in that 10-year period. So that's what it counts for that right there, for that dot right there. Notice here too that we have our scale has been set up here. Yours isn't. So you would need to make sure your scale is set up. And if we set it up like this, then you can see when you start at 0 and go to the first line, 0 to 10, all of these lines in between then end up being counted as 2s. So 2, 4, 6, 8, 10, and then the same all the way up. So that means 2, 4, 6, so right in the middle of that, on that line, on the decade line would be 5. And it's red, we're making drought red. Okay, so the next line, I don't know why exactly, but it did not get put all the way over on the next decade. The next decade shows that there were 6 droughts from 90 to 99. So it should actually be over here. Disregard that dot. I don't know why or how that got there. We can show from here at 5 to the next decade is 6, and then we can keep on going. The next decade, drought 20 to, or 2000 to 2009, there were 8 droughts. So we would go to this line and go 2, 4, 6, 8, and dot right there. And then the next line would be what? It's 8 as well, right? Next decade. Okay, so we would put another dot out here, intersecting with our decade line, and it's right at 8. And I've got rulers that will help you to draw straight lines, and then you just connect the dots.
Wait, I can't see. Oh, wait.
Do the same for each of the events.
Sorry.
Makes your storms blue. So what we
Oh, 1990, 1999.
I'm going to go up
6.
finish this, and then make sure you label.
Then it's 8. And 8.
And then turn it over, and then finish backside and then turn that on. The backside is some analysis stuff, and then there's another chart on the left-hand side that has all the answers to the questions that's being asked.
Don't understand any of this.
When you're finished, if you have makeup work, you have probably a little bit of time to do that. Work steadily, you can get this done.
Yeah. Wait, some good questions? You said we got answers? He said he talked too fast and he moved too fast. Oh, well. Help. So bad. That shit. Glah. Boom. I'll be back. I'll get you in the bathroom.
Okay, y'all. So I'm in the bathroom now. I just gotta use the restroom or whatever. And now I'm fit to go back in the classroom. But I wanted to talk to y'all. Right now I'm in science class. You're wondering why I'm trying to talk quiet. So I'm actually still in school. I'm gonna go back in the science room after this. I got orchestra class. But yeah, so I'm gonna go back in the classroom and I'm gonna get back to y'all when I get back in the classroom. Peace. Hold on, I'll be back. Okay, y'all, I'm back.
Alright, sure. How you draw that? Because I don't know how to draw that straight line. I'm not good at straight lines. Okay. Alright, let's see. Line to the other side. Right? I did it. Look what she watching. I'm not gonna get copyrighted, so I'm gonna get y'all a little bit. But look what she watching. Did y'all see what she watching? Yeah, I just said peace. Okay, y'all, so I'm out of school. I'm supposed to take perspective tables, but I didn't know what bus I was getting on, and they didn't tell me, so I was like, I'm just gonna go home. And I just get my work done. I get my work done at home. But she finna play music, so I'm finna I'm gonna talk to y'all when I get home, and then that's when the video get ended. So.